Good morning and good afternoon, everybody. I am Praveen from marketing team of Tata Elxsi. I welcome you all to the Automotive Summit 2020 hosted by Tata Elxsi on sustainable mobility solutions. Today's session is on assistance to autonomous, the journey, and we will be listening to Dr. Gobinath, who is the senior technical architect for autonomous driving, and Mr. Dheeraj Gupta, who is program and customer engagement manager in industrial design at Tata Elxsi. We encourage you to ask plenty of questions, and at any point during the webinar, you may type in your questions into the Q&A chat box, which will be visible on your window. At the end of the presentation, we will be taking up your queries and will answer as many as possible. Now, let's move on to the session. Dr. Gobi and Dheeraj, it is a pleasure to have you with us today, and I request Dr. Gobi to begin the session. Over to you, Dr. Gobi.
Thanks for the nice introduction. Hi, I'm Gopinath. I would first go through the agenda part of today's talk. This talk starts with a quick overview of Tata Elxsi along with an introduction to our automotive business unit. We would like to emphasize on the global automotive trends and challenges along with our experience in addressing those challenges, starting from advanced driver assistance systems to autonomous driving. We will be touching up on our competency and solution offerings to cater the various needs of the customer in the global automotive domain. In this talk, we also plan to showcase our ADAS and AD solutions with few video demos. We also highlight an OEM case study on our autonomous driving solution and our value of being a technology partner to our customers. Tata Elxsi is an integrated design, engineering and technology-based company headquartered in Bangalore, India. We do consumer research, technology consulting, product design, development, testing for various industry sectors like transportation, broadcast, communications, medical, and next generation technologies. This is enabled through a core team of 7,000 strong engineers and technologists who work from different locations in India and service our global clients. In automotive, we work for the last 20 years and bring together a world-class embedded mechanical testing, AI analytics, and IoT practice, along with an award-winning HMI team backed by ASPICE process. With these enablers, we are driving solutions for connected, autonomous, and electric cars of the future. As a trend, we could see from the driver assistance systems and on the autonomous driving that there are two different kinds of customers. One, a traditional OEMs aiming to bring more and more ADAS features into their vehicles, and the second category of players aiming to produce a level 4, level 5 autonomous vehicles. As a trend, we could observe that the regulators and automotive safety bodies such as Euro NCAP are increasingly including ADAS features like driver and passenger monitoring in their roadmaps for improved road safety. Increasing safety needs drive the industry players to come up with improvements in their perception algorithms accuracies for detection and prediction of objects on the road. Usage of machine learning and artificial intelligence techniques along with sensor fusion helps to optimize the system performance. A connected environment with the AI-powered collision warning systems and perception technologies is driving the automotive industry toward the more futuristic AD. As mentioned in my previous slide, the global trend of looking for higher accuracies of object recognition problems, penetration of more and more AI and machine learning techniques into the solution space of traditional image processing algorithms and increasing need of more and more perception sensors in order to get 360-degree perceptions of the vehicle, either to address the assistance of the driver or to mature the vehicle levels from high to fully autonomous. All these needs bring a lot of challenges and hence a lot of opportunities for us. On the challenges of developing new features, the global automotive OEMs and suppliers are focusing heavily on creating a comprehensive ADAS platform which is built on a combination of features and capabilities across diverse platforms. A good trend on developing a domain controller, I could say as an example here. There are increasing needs of high performance accurate sensors and a reliable as well as accurate model of vehicle surroundings. There are different kind of a perception sensors such as camera, radar, and then infrared sensors will help in realization of autonomous driving features. There are challenges which are due to the increase in architectural complexity and computational requirements, which again require solutions which will balance the performance at the same time a cost-effective solutions in an appropriate way. Due to the increased use of more and more AI and ML models for improved accuracies, again will require more data for their trainings, and hence there are relative challenges such as annotating the data or getting data for which could cater or which could capture different driving scenarios. Safety is an important aspect that needs to be addressed as a part of a hybrid system where there is a traditional along with AI ML models where these challenges to be addressed in a very seamless way. Being in the automotive domain for more than 2 decades, we bring a lot of value to our customers with our extensive experience in addressing the challenges for ADAS, active safety, and autonomous driving solution developments. Our solution offering ranging from system requirements to multi-core platform software development for ADAS and AD applications. Few examples are depicted in the picture where we started our journey long back from 2008 in developing the driver assistance systems in the context of monitoring and giving information to the driver as an alert. Few examples such as surround view system, which is a camera-based systems along with an object detection example, and rear view camera systems are some of the programs where we work with our customers. And in this development of ADAS, active safety systems such as adaptive cruise control, forward collision warning systems, lane keep assists, Tata Elxsi brings the value of engineering service offerings as a software tier 1. Yes, we have started our ADAS journey as well as our autonomous driving journey from 2016 to address the future technology trends by the development of autonomous driving software and the development of prototype autonomous driving vehicles, for example, a robotaxi concept vehicle, I can say. In our journey, ADAS Towards AD, we can proudly say that we have contributed to more than 35 plus production programs for various vehicle variants, and we bring in our vast experience and the competencies to our customers on video analytics and image processing area. Our journey continues to focus on the AD and ADAS design and engineering solution offerings for the connected, autonomous, shared, and electric vehicle domains. The design aspects in the development of futuristic ADAS and AD solutions becomes an integral part of our solution offering. I would like my colleague Mr. Dheeraj to share some of his experience on the design aspects.
Thank you, Gopi, for introduction and taking us through ADAS and autonomous driving evolving trends and challenges. Just to second you, I would like to bring design and strategy perspective to this ecosystem. Automotive industry have come a long way from being pure mechanical and analogous to ADAS, V2X led, and then striding towards autonomous levels, partially conditional and fully autonomous seems not far from reality. As the entire ecosystem has been evolving with unprecedented pace, drivers, passengers, experiences, behaviors, expectations, apprehensions has also seen a dramatic shift. Interaction that were pure, analogous, and functional at one point of time has been now paced to multimodal, fully digital, and other complex touch points, which delivers the advancement in autonomous segment. And design has been an indispensable part in this transition by delivering the experience aligning with autonomous ecosystem needs, by building the trust between vehicle and driver, passenger, subsiding the apprehensions, convey the limitations, and overall defining and designing an experience which is rich and tech savvy, yet intuitive and easy to comprehend. Most importantly, safe, the one user can trust and control with sense of command. Overall, to summarize, design-led strategies holds a vital key in realizing successful autonomous ecosystem across levels. Tata Elxsi has well established and industry proven automotive design practices. We deliver design values to our global automotive customer base from our design studios in Bangalore, Pune, Mumbai, and London. We have design expertise across user and vehicle segments, being traditional fuel, hybrid, or EV vehicle segments. We have executed good amount of autonomous design programs for OEM suppliers and have been in multi-year engagements with the top OEMs and tier ones. Overall, we have four major solution areas which cater to end-to-end autonomous design and autonomous design needs of OEMs and tier ones. Starting from evolving autonomous driver and passenger experiences, this is to set up the right insights and strategy in place. A transaction into autonomous ecosystem will drastically transform the experience from passengers and drivers perspective. Empathizing with user to understand the evolving behavior trends, usability trends and analysis, and identify key interactions, touch points, and creating use cases are the solution modalities. The other one is a connected car ecosystem, transforming the data from fully connected autonomous ecosystem into potential value propositions for the user. It's vital for a seamless experience. It is delivered through device agnostic experience and remote interactions at an advanced level. Automotive HMI design. The human machine interfaces is not only a communication bridge between driver and car itself, but it is also a principal connector between driver and outside world. And this is delivered through IVI and infotainment, design visualization for ADAS feature, multisensory interactions. The other one is autonomous vehicle management platform. This is an important and critical piece of outside car autonomous ecosystem, wherein the remote monitoring IEF-based data analytics serve the purpose of remote performance monitoring, vehicle status, and support and assistance. Tons of data being generated, mined, processed, and provide insights, which needs to be designed to visualize to convey the right intent and serve the purpose of bringing in the safety and control aspects. Here are the service buckets, underlying services and key enablers of automotive design solutions. Design and strategy is one, which is to emphasize and understand the ecosystem needs and lay a strategy. Uh, Underlying services are understanding evolving uh, driver passenger behavior in autonomous ecosystems, automotive HMI UX strategies and innovation, trend research and benchmarking, strategizing the HMI design in conjunction with development technology, basically to convey what tech can offer. UI UX design, which is to realize and innovate design solution. The underlying services are creation of user journey maps by identifying key uh, interaction touch points, information flows, uh, information architectures, framing layouts for the HMI interface concepts, digital and cognitive ergonomics analytics, minimizing driver's distraction with intuitive and sophisticated UI designs, creation of visual design assets, style guides, and also to animate reviews and demonstrate to bring life into new HMI visualizations uh, are the underlying services under UI/UX design service bucket. Another important service bucket is prototyping and simulation, which is to near product visualization and assessment. Underlying services are high fidelity digital click-through prototypes, prototype simulations for usability testing, uh, design support throughout the implementation, HMI validation testing and prototyping. We will take you through a couple of case studies which we have done in autonomous vehicle segment. This particular piece of work, we have delivered HMI strategy and solution for L4 autonomous environment, which was safety critical and complex interactions. Uh, we have orchestrated the entire experience and laid out a viable HMI strategy stitched around encompassing ADAS, TMS, navigations, secondary controls, MRM, driving style, mode confusion, advertency, and most importantly, transfer of control. For instance, defining handover, takeover, transfer of control mechanism, which is a core, crucial, and safety critical aspect of entire experience. We have provisioned, as you see on the screen, right inside the screen, we have provisioned autonomy active confirmation. This is through autonomy mode lighting, dedicated L4 pop-ups display, which will only be available in case of autonomy is activated. Uh, Also, autonomy available indicators. This is to give drivers cues to find out whether the car is ready to take control or not. HUD for autopilot indicator, activation control on steering are the indicators for a driver to know about availability of autonomy. Also, autonomy activation controls, which are provided at steering wheels for easy access and operability to activate and deactivate autonomy. Also, a dedicated display is provided for crucial informations, uh, be it to show infotainment features, controls, L4 navigation, zone assistance, trip infos, and such sort of informations. A short video is next to showcase this entire mechanism, demystifying its complexity, which we have achieved through our expert design and strategic interventions.
Autopilot active. Autopilot ends in 2 minutes. Please take control.
E-cockpits too come a long way, evolving along with autonomous ecosystem from pure analogous to digital and beyond. We have showcased this HMI concept in CS 2020 this year, uh, which is in tuned with autonomous driving needs and scalable to meet the expectations. Very well received by audience. Both cluster and IVI provisioning buttonless environment enabling towards pure digital interactions and voice assistance, big screens and visitor based design which facilitates a scope for a lot of customization and personalization, 3D based ADAS and V2X features, alerts, notification, and novel look and feel, which is very well merging and reflects the context of advanced technology. Over to you, Gopi, from here.
Thanks, Dheeraj. Over the journey of developing competencies in ADAS and autonomous driving, Tata Elxsi also developed several solution accelerators. We would like to showcase our ADAS portfolio with two sample case studies, starting first with a 3D surround view system or bird's eye view system, followed by a VOSYS, which is nothing but a vehicle operator environment observation system. Surround view systems are assisting the drivers to get the entire 360-degree view around the vehicle. SPS solutions, which is developed, are already licensed to one of the tier 1 for a production program which is currently in development stage. The views of surround view system solution is available both in 2D and 3D. The experimental setup for evaluating the SPS software ported and optimized for a TI TDA2X platform is shown in this slide. There are 4 numbers of OmniVision HD image sensors along with 180-degree field of view fisheye lenses are employed in this experiment. The GPU of the TDA2X platform is used for 3D rendering. Free eye view point control feature is also available and can be enabled through the joystick. Real-time performance of the SPS software is achieved on the target platform, which is around 30 frames per second. This solution can also be extendable to support 6 or more cameras for a larger number of vehicles, as well as this SPS software can be easily ported in other hardware platforms. According to Euro NCAP, 90% of the road accidents are caused mainly by the driver inattentiveness towards their driving. Monitoring and informing the drivers can effectively enhance the road safety and in-cabin experience for all the vehicle occupants. The Vehicle Operator Environment Observation System, shortly called as VOSYS, is Tata Elxsi's active safety solution to monitor vehicle in-cabin environment using multiple cameras and vital monitoring sensors. Some of the features such as driver monitoring, occupants and their emotion detections, along with the left behind or a threat object detections can be evident from a small video clip on VOCs. Features such as child detection, gesture-based control, a seamless transfer of control from driver to autonomous and vice versa, cloud connectivity, and health monitoring are some of the other features which have been planned for the future versions of VOCs. Let me play the small video on VOCs to showcase the different features. We have invested significantly over the past 5 years in developing the autonomous driving competency by bringing together the experts across areas right from data acquisition and processing, perception and guidance and navigation algorithm developments, data science and analytics, vehicle integration and validation, development of autonomous driving software, implementing this AD software on an OEM's test vehicle, development of auto parking proof of concept derived from autonomy, and the level 4 robotaxi concept vehicle development are the significant milestones of our autonomous driving journey. Tata Elxsi's autonomous driving initiative started in the year 2015 with the development of autonomous driving software called autonomy. Autonomy software is designed in such a way it can help the automotive companies, OEMs and Tier 1s to rapidly build, test and deploy customizable ADAS, active safety and autonomous driving applications. This software has two major subsystems, namely perception system and guidance, navigation and control system. As well, it provides an integration with the various types of perception sensors like camera, radars, lidars, and driver-aware systems to enable the vehicles autonomously with less or no human involvement. The multi-modal sensor-based perception system perceives the environment surrounding the vehicle and builds a map of the environment. The on-road objects such as vehicles, pedestrians, and the road infrastructure details such as lane markings, traffic signs, and signals are detected and classified by the perception system. The guidance, navigation, and control system then extracts the drivable region and performs localization, path, and motion planning based on the perceived information map built by the perception system. And it issues the necessary high-level commands to the driver system. The modular architecture to suit the customer needs, either in the form of full middleware or as a subsystem or as a specific advanced application development, and the plug-and-play architecture for easy porting, optimization, integration, and testing for customer systems or algorithms, along with the supporting to multiple perception sensors to suit the customer requirement, then enabling with a rapid region-specific adaptation features are the significance of autonomy software stack. It is also licensed to a global top 5 OEM in Europe, and we could achieve a level 3 plus connected autonomy features which are all tested, which is on a test track as well as on a public roads in Germany. Autonomy's SenseFuse is a multi-object, multi-source, and multi-target information fusion framework for perception systems. It is designed with the following significant features such as high precision and reliability, robustness to uncertainties of the sensors, extended spatial and temporal coverage. The SenseFuse is aimed at enabling the OEMs and Tier 1s to develop various autonomous driving and ADAS use cases in a faster and more effective way. A high-level architecture of autonomous SenseFuse, which is a sensor fusion engine, is shown in this slide. A SenseFuse provides a 360-degree perception by combining the competitive and complementary information from multiple perception sensors. SenseFuse package is designed to support different fusion strategies such as object level fusion, track level fusion, and raw data level fusion. It also supports fusion of multiple sensors of different types of camera, LiDAR, radar, and same types such as multiple radars, cameras, and so on. By the use of Configuration Manager, a user can select the appropriate sensor configuration, and he can also select the corresponding fusion strategies. The fusion strategies also include a homogeneous and heterogeneous fusion in both 2D and 3D, raw data fusion, track-to-track fusion, and multi-sensor information fusion. There are probabilistic and rule-based fusion methodologies are employed to generate the fusion object list. The fused objects are then tracked using the multi-object tracking, which includes data association, filtering, and track management. Multiple filtering strategies such as Kalman filter, IMM filters, along with multiple association techniques such as joint probabilistic data association and nearest neighborhood algorithms are also supported. Visualization of the fused and tracked object list along with their corresponding performance measures can be derived from the SenseFuse package. For a given sensor configuration, once an appropriate fusion and tracking strategies are configured, an executable file can be generated from the SenseFuse. This executable file can then be ported on a target platform, for example, an NVIDIA TX1 GPU system, to perform the fusion of the data from multiple real-time sensors such as camera, radars, and lidars. It is then further integrated to the ADAS or AD ECUs to perform a very specific ADAS application or autonomous driving functionalities such as a lane keep assist or a traffic jam assist, or it could be a truck autonomous parking kind of an applications. For frequently used parking scenarios like garage or reserved parking, the park by memory based auto parking systems can be used. Tata Elxsi's park by memory system, which is an auto park assist ADAS system, which can take control of the car and to drive it from the drop-off zone to the parking and from the parking to the pickup zone when initiated by the user. The reference parking maneuvers are learned by the system through manual driving in training mode. When triggered by the user, the car parks by its own, using its intelligence to perform path and motion planning along with obstacle detection and collision avoidance by safe stop feature. Park by memory feature can be easily configurable and it can be adapted to both open and enclosed parking scenarios. There are other features such as parking slot detection, infrastructure assisted parking, auto valet parking, and obstacle avoidance by circumventing are in the roadmap of our auto parking solution package development. A video demo is to showcase Tata Elxsi's auto garage parking, which is a park by memory. Here, I would like to present the development of Robotaxi, which is a level 4 autonomous vehicle demonstrator to showcase Tata Elxsi's competency in autonomous driving domain. This concept vehicle includes onboard sensors such as AI's IDAR sensor, which is an intelligent LiDAR plus camera combination of sensor, radars, and industrial PCs as computing platforms equipped with autonomy, which is our autonomous driving software stack, and the drive-by-wire systems. The onboard LiDAR sensors based high-definition map was created by driving this vehicle inside our Technopark campus at our Trivandrum location. The simulation studies are performed by using Carla, by which we could able to virtually validate the software stack before the vehicle testing. The demonstration of level 4 autonomous driving scenarios are tested on this robotaxi vehicle, which can be witnessed through the following video. And another milestone of Tata Lexi's autonomous driving journey is the successful implementation of autonomy, which is the end-to-end autonomous driving software stack on an OEM's test vehicle. A team of integration and development experts from Tata Lexi worked on-site in Germany at the OEM location, as well as in offshore in Tata Lexi India campus, to integrate the autonomous software suite for the test vehicle. The OEM's test vehicle was equipped with an edge-processed camera sensor, and there are radars and LiDAR sensors along with a drive-by-wire systems. Tata Lexi's team, along with OEM team, have tested various levels of autonomous driving features such as stop and go, distance keeping, lane changing, and V2X features such as green light, speed, optimized speed advisory, which is called GLOSA, and lane change advisories. These test cases are also including by handling the intersection scenarios, as well as there are vulnerable road user scenarios are also handled here. Autonomous driving testing were performed both on a test track and subsequently on a public roads in Germany with a vehicle speed of 30 km per hour at the initial phase and then it has been increased to 50 km per hour. Realizing various autonomous levels such as level 4 and level 5 can be achieved with the ecosystem partnerships between OEMs, sensors, hardware suppliers, and software suppliers, and many more. In such ecosystem, for realizing the L4 and L5 autonomous vehicle applications, Tata Elxsi is in technology partnership with AI, the IDAR sensor supplier. AI develops an intelligent LiDAR plus a camera integrated into this sensor, whereas Tata Elxsi join hands with AI in the development and optimization of a deep learning based perception stacks for integrated 2D and 3D perceptions. It also involves in the development of different perception features such as distance, object orientation, tracking, and velocity and motion forecasting. Augmented data generations and augmentation of traffic sign, instance semantic segmentations using the TensorFlow plus PyTorch and Keras frameworks are the significant in the development of these perception stacks. The proof of concept of using an IDAR on Tata Elxsi's robotaxi platform, which is powered by autonomy, was showcased in CES 2020. I would like to conclude this talk with the following notes on our future focus areas in ADAS and AD journey. As we see more and more AI and ML based perception systems are penetrating into the automotive domain in search of higher accuracies, we also need to ensure the functional safety aspects are correctly addressed for those neural network model based perception systems. Techniques like reinforcement learning are also another focus areas for adapting autonomous driving for challenging environments. Developing the cost-effective ADAS and AD solutions along with auto parking feature development such as intelligent park assist and auto valet parking, as well as the corresponding validation services for those level 4 and level 5 autonomous driving features are our future focus areas. With this, we would like to conclude our talk here. Thanks for your time and patience in listening our talk. Looking forward to the Q&A session.
Thank you, Gobi and Dheeraj, for that wonderful session. Now we have a couple of questions from the attendees. Maybe we can take those questions one by one. So the first question is, you spoke about evolving autonomy. How close this is to hit the market? What's your reading on set of challenges lying ahead? So
Yeah, I would like to take.
Okay, thank you. Please go ahead.
So I would in fact add, the design role in here. It's pretty relevant in current evolving context, and there has been excitement and eagerness in the market, and the technology also has evolved to an amazing extent to deliver this dream with conjugation with design-led strategies and delivering right driving experiences. However, there are infrastructure needs, regulatory frameworks, and other constraints which needs to be worked upon in tandem with the design and technology evolutions which are happening to meet the overall ecosystem demand. Also, a bit of learning curve is required from various levels of autonomy and being without autonomy, right? So there's a tremendous shift happened there. So also a bit of learning curve is required to adopt new way of driving and mindset. So design plays a very critical role here in keeping that curve very shortened, and also by defining, the interaction system which are very intuitive, easy to understand, and yet conveys the idea and the comfort of higher autonomy. So overall, we are very close, but not very close. Also, to add one more point here, it's about the trust factors, which are very important if you talk about self-driving vehicles. So trust is like a gas in today's car. Uh, it means, it's the confidence which a car or a vehicle will provide its driver to the drive to the destination safe and sound, and act according to the driver's expectation, and on top provides an enjoyable experience from high-end features. So yeah, so we are there. So our reading is we are close, but yeah, it will take some more time. All aspects like infrastructure, as I mentioned, regulatory frameworks and technology design, both all should evolve and uh, come to a point where it is realized. And we are very hopeful, very confident. It will happen soon. Thanks.
Thank you, Dheeraj. Let's move on to the next question. For a particular sensor configuration, how the fusion pipeline of autonomized sense-fuse solution can be selected? Dr. Gobi, would you like to take this question? Okay.
Yes, Praveen, I can take up this question. Yeah, so the sense-fuse solution of autonomy is basically a sensor fusion where there is a configuration manager which is available through which the user can easily select a particular sensor configuration of their interest. And the same configuration manager, he can also select what kind of the fusion pipeline that he wanted to, or the user wanted to select. So by selecting an appropriate algorithms, either it could be a 2D fusion or the 3D fusion, and the necessary algorithms corresponding to that, because SenseFuse has multiple algorithms to address this sensor fusion. And after doing the sensor fusion, we get the unified test values or unified object values, which will get then tracked by a tracker module. So again, the user has to select what are all the appropriate data association techniques which needs to be selected in order to finish the pipeline, entire pipeline. So that's the way one can select the necessary or the required sensor fusion pipeline. And once it gets selected, you can also evaluate that using some offline data sets. There are benchmark data sets like Kitty or New Scenes data sets which are available, through which one can evaluate certain performance measures, as well as it also provides certain visualization clues in terms of how well your sensor fusion as well as the tracking performance is happening. So through which it will be very easy for anybody to quickly work on that tool and then select a particular fusion pipeline using this autonomy SenseFuse solution. Yes.
Okay, thank you,
Yep.
Dr. Gopi. Yeah, we have another question. Is path to L4 features through L2, L3 features, or are they very different?
Okay, I can take up this question. See, obviously, these levels which have been defined by the Society of Automotive Engineers or the National Highway Authority in US, so they have selected or defined these levels of autonomy from, say, level 1 to, say, level 5, whereas up to level 1 to level 3, people are talking about only as an ADAS application. It is mainly the driver will always be there in the loop of in loop with the controls of the vehicle. Whereas there is a paradigm shift which is happening from an L4 and L5 level of autonomy, where in the case of L4, which is highly automated vehicles, where for a very specific use cases or very particular kind of an applications, the autonomy functions will be active. But at the same time, with the safety in constraint, the driver is always there in the loop of that. And when we are talking about a fully autonomous case, which is an L5, where the dynamic driving task, which we call it as a DDA, which is entirely handed over to the vehicle, and there is no concept of driver assistance there, because there is no driver at all in L4 and L5, whereas you'll still talk about an L1 to L3 feature as a driver assistant features, right? So that's a key difference between L1 to L3 as well as then L4 and L5, right? The way how one can achieve this maturity is it cannot happen by overnight, that my vehicle or my entire autonomous driving is ready or autonomous vehicle is ready. So it can happen in a periodical advancements which is happening, and that's and it has its own roadmap in order to achieve. As my colleague has correctly mentioned, there are infrastructure requirements, there are safety and security related aspects needs to be addressed in order to reach from say L3 to L4 and then L5, right? So hope I'm able to answer that question, because yeah, so it takes its own time, and the way how one can mature from an L2 to L4 is by keep on adding the different kind of functionalities one by one into the existing vehicles. That's what the traditional automotive OEMs are doing, and but there are players where they are like, could be a startups, or they wanted to directly jump into the L4 and L5 vehicles and making the robo taxis, and then they are also doing certain testings on that. But both of them are going in a parallel track in order to achieve their goals in that perspective. Yes. Yeah.
Yeah. Thank you, Gopi.
Yes.
Since we are running short on time, maybe we can take 2 more questions before we call today. So the next question is, what would it take to reduce catastrophic failure rates of an autonomous vehicle fleet? As we all know, vehicle level testing is not enough to ensure safety. Yeah, so Gopi, would you like to take that question?
Yeah.
Should I repeat it? Did you get the question?
Yeah, you can yeah, give a quick repeat on that question.
Yeah.
So it's talking about a catastrophic failures, right?
Yeah.
Mm-hmm.
Yeah. What would it take to reduce the catastrophic failure rates of an autonomous vehicle fleet? As we all know, vehicle level testing is not enough to ensure safety.
Okay. Okay, since we are talking about the safety levels of implementing these autonomous vehicles into the environment, so there are multiple levels of testing. Even before vehicle level testing, we need to ensure the safety at each and every function levels of the software what we are talking about, which is going to run that entire vehicle. Because in future, where the L4 and L5, there are a lot of lines of code, which is, it's going to be a million lines of code which is going to be there in the vehicle. So it's all going to be a software driven perspective. So ensuring the safety at every function levels of the software, which is going to take a particular decision or a perception, or could be an object detections, or planning a particular path, could be a planner software which is sitting on that autonomous vehicle, right? So in order to ensure the safety levels, not only the functional testings, but also we need to ensure all the different corner cases which needs to be addressed when we are doing a bench level testing, could be on a sill mill or a hill levels before even taking to the vehicle, right? So another thing is when we are talking about vehicle level testings, we also ensure that how these particular vehicles, when I'm going to deploy them in an actual scenario where it's a combination of both a drivered vehicle as well as this autonomous vehicle are going to be play in the road. So in such a cases, we need to ensure that how this cooperative senses are happening between the vehicle to vehicle. That's where the C2X or vehicle to vehicle communications are becoming more and more important in order to reduce the overall the catastrophic effects in terms of the safety perspectives, right? So we have to ensure at every levels the safety aspects so that we can totally avoid this the catastrophic failures when we are actually going to deploy them as a fleet of autonomous vehicles on the road. Yeah, but people are, yeah, we are still working on that. We are yet to reach that particular levels, but the goal can be easily achieved. That's the and that's where there are Teslas and there are Google cars and GM. There are multiple OEMs are working towards achieving that goal. Yes.
Okay.
Yeah.
Thank you, Bobby. So maybe we can take the last question of this session.
Yes, please.
You mentioned about driver monitoring systems. What are your views on different types of monitoring like active and passive monitoring?
Okay. If I'm understanding the question correctly, it's a kind of an active safety or a passive safety kind of a systems, where when we are talking about an active safety systems like this vehicle monitoring, cabin monitoring, or the driver monitoring solutions, where the passive monitorings are not going to help you in terms of or the passive monitoring is majority using certain kind of a statistics or the overall data recorded, and then it will be analyzing there at a bench levels or at control center levels. Whereas I can give an example of a passive monitoring, something like how the traffic flow is happening. That means you fit some a camera in the traffic signals and then keep monitoring that how much of vehicle flow is happening, and then is there any kind of near crash events or anything is happening in that sense, right? Those are all passive monitorings, whereas the active monitorings are really going to help or avoid the crash of the vehicles, as well as it will also be helping the in-cabin vehicle in-cabin occupants inside the vehicles, right? So that's the major difference between this active and passive monitorings, right? And more another examples also I could say that say passive monitorings or passive safety systems like airbags and other systems can be of help once the accidents are already happened and then it is coming and then acting on that, whereas the active monitorings are really helping in terms of avoiding the accidents are going to happen. That means it proactively sends that the situations and then avoid such situations in that case, right? Yes, Praveen. Yeah.
Okay. Thank you, Gopi.
Thank you.
So though we have quite a few questions, because of the time limitations, we are not able to attend to all the questions. So I'm afraid we may need to skip some of the questions. Dr. Gopi and Dheeraj, thank you very much for your excellent presentation and the support for the question and answers. And ladies and gentlemen, now we have come to the closing of this particular session. But I would like to let you know that the webinar that we presented today will be available on demand for you to rewatch or sharing. And once again, thank you everyone for attending the session. And we also have other sessions planned in this series of Automotive Summit 2020 on spread across multiple days on these 2 weeks. So please register with us to join for other sessions. Now, thank you and goodbye. Have a nice day. Thank you. Yeah.